Good afternoon, class. We are finishing up section 1.6, sequences and difference equations, part 2. This example says, Pacific salmon population have discrete breeding cycles in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species. So there are two types of recursion, and we want to see which one gives us more. Okay, so I'm going to read part A with the solution as follows. Part A, suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with a probability of D, meaning D%, 5%, 10%, 20% will be preyed upon, and the rest of them remain. So if D is 5%, 95% remains. If it's 20%, 80% remains. After swimming upstream, each fish produces B offsprings before dying. So they get multiplied by B, and then because they die themselves, it's just multiplication by B. The stream then is stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey. So here's what happens. How many fish do we have? X, Y, Z, whatever the case might be. I'm going to go with N sub T, everybody. The time step. So this many fish start the journey. As they go upstream, the very first thing they come across is dealing with bears. So a percentage of them will be gone. The way we write that is N sub P is N sub T minus D times N sub T. So it's easier to follow here. 1 minus D times N sub T, meaning D is the portion fraction percentage that is gone. So what is left is 1 minus D times how many we have. Now, each fish gives us what? B offsprings before dying. So simply put, multiply this one by B. So again, explanation would be N sub P plus B times N sub P minus N sub P. This one because they die. So simply put this times B. Finally, we add N. So this is what we recap. We have this many fish. They go upstream. Before anything happens, the first thing, the percentage will be gone because they are preyed upon by the bears. They get up there. We multiply by B because each one gives us B offsprings, and then we add N. Done. Part B, suppose that instead of preying on fish while they swim upstreams, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population? Again, assume there is no mortality while at sea. So we have, as they go up, nothing happens. So they get up there, they get multiplied by B because they give us B offsprings and they die. Then we add N. Add N. So number of fish at time T. Each fish produces B offspring. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. As they swim out to sea, predation happens, and this percentage will be gone. So 1 minus D times this. A quick recap. How many do we have? This many. They get up there, they give us B offsprings and they die, so they get multiplied by B. They're coming down, we add M fish. And the last step is dealing with the bears. This is the percentage that will be taken out by bears. Now the
Professor?
question is, yes,
Oh, I'm sorry. On the slide before, the one minus D, how did you what does the one mean? Like, how did you
it's
get?
we have 1 means 100%.
Oh, okay.
D is the percentage that is gone. So if 10% is gone, 90% remains. D is a probability or percentage or a fraction that gets preyed upon.
Oh, okay, I see.
Does that make sense?
Yes, thank you.
Okay, sure. This is called complementary event. So if 10% is gone, 90% remains. So 1 minus the percentage that is gone. All right. Now, which of the recursions obtained in parts A and B predict the largest increase in population size from 1 year to the next? Justify your answer both mathematically and in terms of the underlying biology. And of course, D is a percentage, it's a fraction, it's a portion between 0 and 1, okay? And of course, B is positive and so on. All right. Mathematically, it's very simple. You can say part A minus part B. The result, if it's positive, part A is larger. If it's negative, part B is larger. So again, part A minus part B, the result is either positive or negative. This one we multiply. This one is B minus BD times n sub t, and this one we multiply these two, multiply these two, we multiply these two foiling. So this is what we get. So a quick recap. This one will give us b times n sub t minus bd n sub t plus m minus, this gives us 1 times b and t plus m minus db or bd n sub t minus md or dm. This one we don't touch. This one, every term changes the sign. So this becomes negative, negative, positive, positive. This one cancels out this one. This one cancels out this one. This one cancels out this one. MD, and you know M is positive, the number of fish that we added, so is D. So because part A minus part B is positive, part A must be larger. And it makes sense because in part A, all the additional fish survive. In part B, all fish face predation. So in part A, the M that we added, those, they all survive. Over here, also they are subject to dealing with the bears and predation.